Welcome to Brain Vision.
So I'm going to solve the interview question. It has two parts, where in the first part it is asking, show that work done by a constant force, and then how you can prove it is constant force is conservative. Force is actually conservative. Constant force, where force is not varying with position, time, or velocity. Now I'm writing the basic definition of work done. Basically, in physics, work done is what is work done mean is when force is applied to an object goes to displaced its position, or object goes to change its position. Then when object goes to change its position, work done is happening there. If I say mathematically W, which is the notation of work done, is equal to F dot dr, and integration of from initial position to final position. Now we have force, which is constant, which is not varying with initial or final position or time or velocity. So we can keep it out. I mean, we can pull it out from the integration. Then we will have only uh, dr, and if I complete the integration, I will l- have this expression as f dot rf minus ri. What it means and how it is defining that this force is conservative. Now I'm adding in this diagram where A is my initial position and B is my final position. This equation mean that work done depending only the final position and initial position, no matter which path it is for object is following to go to uh, initial position to final position. That doesn't matter, it is following curved line or a straight line, but only both two position difference of both two position matters. When work done only depends on two final initial and final position of the object, then work done by this kind of force is called conservative force. Because work done now is path independent, only position of final and initial position dependent. So this is called conservative work done by conservative force, and um, this is clear from this formula in this equation 1. Now in the B part, I have a given diagram where my initial position is 0, or coordinate 2D diagram. This is a 2D diagram, and initial position is 0, coordinate is 0, 0, and final position is C, coordinate is 5, 5, which means along the x-axis it has 5 uh, numerical value 5. Along the y-axis it is numerical value 5. Now I've also added some more notation. A is along point A is actually on the x-axis, so its coordinate is 5, 0, and B is on the y-axis, so its coordinate is 0, 5. Now I have uh, this formula from the problem A, from the solution of A, F is equal to W is equal to F dot RF minus RI. My F is 3I plus 4J, and I'm I'm calling this three path as a this blue path as path number one, green path as path number two, and red path as path number three. Now, if I try to calculate the work done along the blue path, along the green path, along the red path, that will be W1, W2, W3. Now, along the blue path, I have two parts from O to A and then A to C. If I if I write down the whole formula following the equation 1, I have F dot RA minus RO plus F dot RC minus RA. Now one can choose to cancel this RA because one is positive and another is negative. They will cancel each other. And additionally, RO actually 0, its coordinate is 0 0. So we only have F dot RC, where RC is 5I plus 5J. Now, if I do the vector dot product with the given value of F, I will have only 15 plus 20, which is 35 joule. Along the path to green line, W is equal to actually WOC, where I already showed that RO actually 0, then we will have only F dot RC, which is actually 35 joule. J is joule, unit of work done is joule, and along the red path, I have OB plus BC. A similar way, F dot RB minus RO plus F dot RC minus RB. This RB cancelling each other RBs. Then I only have F dot RC, which is actually 35 again, 35 joule.